have any parables to. We're going to go ahead and get started.
Welcome everyone. Thank you for coming this morning. And today, I present augmented reality with augmented reality. And for those of you that don't know me, I'm Nick Hovitz. And here's my presentation. So, the topics I'm going to be discussing today involve an overview and a history background of augmented reality, where it kind of comes from and where we see it today. Then I will be discussing the relationship between AR and VR. AR, that is augmented reality, and VR, virtual reality. Then I'll be discussing how AR works. Then I will be giving a tutorial to show you guys, whoever's interested, on how I did all this and the main workflow to get all this going. It's kind of funny that I actually have a live demo at the end of it because this is a live demo, but I have a live demo at the end of it to show a semi-practical application of augmented reality, as you see it here. To start off, we will be talking about the overview and the history of augmented reality. For those of you that don't know what augmented reality is exactly, it involves superimposing a computer-generated image on a user's view of the real world, thus providing a composite view. This implies that the 3D objects are being laid on top of, as you can see here, the 3D of our 3D world. This is done by taking the 3D images that are coming through the video stream and taking the 3D objects that are being generated by the GPU and the CPU and combining those two into one compositive view. This definition implies several opportunities. Specifically, in particular, we are able to branch out from the bounds of our 2D monitors. This allows us to transform rooms, any rooms in any offices and schools and stuff, to where we can make the whole rooms an interface, anything with flat surfaces and such. This allows for a new immersion factor to where our lives actually become interfaces. A little bit of the history of augmented reality. It's actually a fairly young field of study. Though it dates back as far as the 1950s, it actually more recently in the 1990s picked up because of the advancement of GPUs and CPUs with all the graphics and operating systems coming around at that time. This, contrary to popular belief amongst our generation, augmented reality is used way more than eye candy. For way more than eye candy. It is used for a lot of practical applications back then and today, which I'm going to show you just a few of what it can be used for. So to start off, Ronald Azuma, one of my sources, speaks about how all the way back in the 90s, doctors were able to use MRI technology to create a 3D model based on the scans that the MRI technology takes of a patient's organ. This is done, as you can see here. It scans the organ, and you can see the state of the organ based on the structure that it renders out of the MRI technology. Another example involves machinery. In this case, the engineer has come to repair a specific component of a big factory. As you can see in the now lit up pipes, that is the area of interest that the engineer wants to focus on. And he's happy because he doesn't have to look at ridiculously old diagrams written by people that worked there 10 years ago. In this next slide, this involves military usage. In movies, we've all seen all sorts of Jarvises and Minority Reports and stuff, all sorts of augmented reality interfaces in the military. This dates back fairly far too. In this case, I'm going to put it a little bit closer so y'all can read it. But in this case, I just have a simple text-based augmented reality pop-up for his flight control. But pilots have reportedly used this for things such as aiming, target tracking, and navigation planning. Now that we kind of have a basic understanding of where augmented reality has come from and what all sorts of things we can use it for, I would like to discuss how AR and VR relate. Taking a look at this diagram shortly, this is a slight relation, a very basic relation between the real world and the virtual world and each environment's components. On the left, that's actually where we see augmented reality. It's when you add virtual components into the real environment, creating the mixed environment as you see there. On the other hand, if you add real components into a virtual environment, you get Mary Poppins. That's essentially what augmented virtual reality is. Another particular one that I actually find kind of intriguing is on the remove row. The diminished reality involves taking virtual components to remove real part of the real environment. This people at first glance wouldn't think that this would actually be that useful. This is actually very useful for construction purposes whenever people are planning sites, big sites, and construction sites whenever they want to tear down a building that whenever they want to build a new building in place of the building that's already there and they're about to destroy it. So another part of virtual reality actually has a really big impact on the way that augmented reality is growing as a technology. Recent advancements of virtual reality definitely have promoted a lot of augmented reality technology lately. Particularly, this is a very, very small list discussing what companies have particularly looked at this hardware. Facebook's CEO has directly stated that they're planning on using, and they actually already do use, virtual reality interfaces in their in Facebook. I actually have shown a lot of you a video of Star Wars exclusive video where you can actually turn fully in a 360-degree fashion and see the video and interact with it practically. At E3 or Electronic Entertainment Expo, this is the most renownedly large E3 this year that hosted a bunch of VR hardware. A bunch of companies weren't even interested in the regular 2D video games. They all came, lots of people came for the VR hardware, and many of the hardware that was demoed there was actually VIP invite only. So we haven't actually gotten that many explicit reports on how it went, but we've got a lot of good, just broad feedback from the way that those went. Even though the hardware is in an alpha state, whereas just barely being able to was an alpha state. So, and as far as Microsoft, they're not only venturing into the virtual reality aspect, but they're actually going more towards the augmented reality, and they have made arguably one of the most robust augmented reality pieces of hardware that's still in development, and they're releasing a developer's version in January. As of a few weeks ago, they announced a release for developers only in January for the HoloLens. For those of you that have not seen virtual reality, I actually have a visual illustration to show what exactly I mean. This is a video that I created with I'm actually creating a video game out of Unity right now, and I recorded this using a 3D panoramic camera, and this video is actually on YouTube and you're able to view it, but because I wanted to keep the flow of this nice and smooth, I just put it in Unity instead. So that's essentially what virtual reality shows. The next thing I'd like to discuss is how AR actually works. we can see in this diagram that it takes just at the very basic level 3 components to have an augmented reality environment. You just need a camera, a computer, and a display. The camera receives images in a video stream. This video stream is caught through the capturing module, which is passed in frame by frame to the tracking module, which evaluates every single frame for a pattern that it recognizes. And it takes each pattern and it notices coordinates of where a tracked object is. And I'll get into that later in the presentation. But whenever the tracking module creates those coordinates, it is passed into the rendering module, where those coordinates can actually be combined with virtual components, creating the augmented image, which is printed to the display, as we can see in the diagram. Some tracking methods that this involves. We are able to use, this is only just a few of them as well, very brief list. Visual tracking, sensory tracking, and a hybrid of any 2 of those, or even more that I haven't listed. Particularly, marker-based and feature-based tracking are some of the most primitive forms of visual tracking, and I actually used feature-based tracking in this implementation. For sensory tracking, that involves anything from, like it says, hand recognition, wearables, think of Minority Report. I've even heard of people using Bluetooth devices and beacons for sensory recognition. That's pretty cool. So, and hybrids involve using markers and wearables and stuff like that. So you can get all sorts of combinations with these and have more robust interfaces. To further explain what I mean by actual markers and features, for a marker, whenever you're tracking a marker, there's only ever one. It's just one small shape that you're actually looking for. And therefore, it's typically black and white because that is the most color contrast that you're going to get out of the color spectrum. I'm colorblind, so I don't know particularly, but that's what I hear. So, and that actually generates 4 corner pins, to where you can use those 4 corner pins to actually determine how the object is actually going to sit, even though you're getting these corner pins from a 2-dimensional environment. Features, on the other hand, you actually use a lot of these. And these, the reason why I use a lot of these is because they're based on color contrasts that occur throughout the image of any sort of color drop-off, essentially. Like blacks against reds and reds against yellows. Whenever it notices those drop-offs, it'll place little features across those little points that show the same drop-off. And with this technology, you can track literally anything you can take a picture of. I took a picture of a bag of Cheetos and was able to track that with, I actually thought of putting my sources on there and saying these are my sources, but I took that out. But so to further elaborate on what I actually mean, this gives a much better representation of what I'm actually talking about. Up here, by the marker-based application, we see the original image with, I'm guessing that's a pen, with the marker and a hairband. That is then gone through a process called thresholding, where all of the color and distortion and noise has been taken out and black and white remains. And because we used a black and white image before, it results in about the same thing anyway, so we can actually form those 4 corner pins off of what we expected anyway. On the other hand, feature-based tracking involves the many pins that you use on color contrast points. Because even though this is a black and white photo, there's still a bunch of color drop-offs. For instance, right here you have a bunch of white, but then it dropped immediately to gray and then immediately to black right there. White to black. It uses all of those points and locates, did it change from black and white from this pixel to this pixel? It logs those relationships in millions of different features. Because we have processors that can handle this much data, this much just very small data, calculating each of these frame by frame, 60 frames per second, we're able to do a lot more feature-based tracking nowadays. Back in the day, they used a lot more marker-based because that was easier on the processor. Here, now that we have the data that we need to actually be able to locate the object and where it is on the screen, this shows how it's oriented and the translation of the object relative to its origin. So as you see here, we have 6 degrees of freedom. The rotation is about the axis X, Y, and Z. That is alpha, beta, and gamma. And then the displacements of X, Y, and Z across the axes appropriately. And I have actually made a visual representation of what this looks like. Here, if we move it left and right, as you can see on the X, if I move it left and right, the value will grow and shrink. Same thing with the Z-axis going in and out. If you rotate it as a roll, the A value will change. If you change its pitch, the G value changes, the yaw, the B value changes. Same thing with the Y. And I actually put those corners right there to locate. That's actually where the marker is. It's actually bigger. I just bought this box from Walmart the other day, and these pictures barely fit inside of it, but that's actually where the pictures are. So if it were being tracked, it's like, hey, this is the whole tracker that I'm seeking. So that shows the representation of where it actually is relative to space. The next thing I'd like to do is show you guys how I even did any of this. Okay. So to start off, I've talked about Vuforia and Unity 5. Unity 5 is a game engine in which the engine runs as the main hub for Vuforia to use its APIs on. So what you actually do is you download Unity 5 first and install it. And you actually have to get the Unity 5 32-bit version because, from what I understand, Vuforia was created originally for the 32-bit version several years ago, and they just haven't switched. So you have to download the 32-bit version. Usually they just throw the 64-bit version at you, but you have to actually go looking for the 32-bit version. And once you have that all downloaded and installed, this is actually what the download page looks like. So it gives you a list of downloads. You can choose the 32-bit version. It's a pretty hefty download, so I'm not going to download it today. And then after you're done downloading and installing all of that, another thing you do is you actually make an account with Unity, and you can sign up for using the personal edition, which is a royalty-free as long as you're using it for your own personal use. It's good for students and good for people that are just getting started on graphics and stuff. As far as Vuforia goes, this is completely free. As far as I know, I just saw that. But anyway, whenever you go here, all you do is you actually download the SDK to get started on. Once, assuming you have Unity already installed, you download the SDK for Unity. They have other SDKs for other platforms as well. And I'll just log in to get to my page. Whenever you log in and you create an account with them, you go to the Developer tab. Then you start off by creating a license key for yourself so that if you do release any of these products, most of them aren't even allowed to, I think that they're allowed to be released for mobile, but you're not actually allowed to build these. That's why I'm running it in the simulator right now. It doesn't allow you to build these in a standalone application. But here, you have to first create your license key. I just created mine, and this is what, literally all you do is click that button, give it a name, and then it generates this code for you. And it's a unique key for your own usage. And then this is the main hub of what you actually use for whenever you're in Vuforia. Here, you keep track of all of your targets. And what a target is essentially all of these things in the box. That's a target, that's a target. I used all of those to actually print all of my 3D objects to the screen. So here, I'll just create a new database right now, and we'll call it, I already have one called Seminar. And then you go to Add Target, and you look for a file. And I've gotten error messages that say if it's not a flat grayscale JPEG file, then it won't work. But I've used PNGs, so I guess I'm just getting lucky. So, okay, that is JPEG. It also asks you for a width, so you have to make sure that you go into the description of the image, because sometimes you render pictures and it'll tell you it's a certain size, but it's not actually, it's lying. You have to go and put this width in there, because this will scale your 3D objects based on what you put in here. So it has to be right the first time, or else you're going to get very skewed stuff. So, target X. Once you have this target in here, this is really cool to me. So this rating right here actually shows you how many features you actually generated in your target. So you can go in here, and this is the image I uploaded. There's a lot of contrast points. It's kind of crazy, but as you can see here, this is the features that it rendered off of it. So, and when you're done doing that, you take this target and you download the data set. You make it for the Unity editor. With this file, you can actually take it and import it into your project, and then you use it. And there's tutorials that can get you started on using their APIs and such. There's tons of different ways that you can use Vuforia and Unity combined. But right now, for example, I'm going to show you one of the things that I have implemented with my presentation. Okay, stop here. Okay, that's probably all the time I need. There we go. Where is this here? And because I'm running out of time, these are my sources, and this actually no, that doesn't work. Yes.
Any questions for Nick? We're going to be transitioning while he answers the question.
Back on when you had diminished and vertical knot, what was the fourth point doing? Because you mentioned the first two.
That's where you take this is the one I don't understand. I don't think I've ever heard of people using this. You take real life components and you remove virtual components of them. But that's, like, I don't really understand the point of that. So I'm sure that some people have found a use for it, but yeah. There were some other categories in there that I hadn't actually listed, but it gets into like metaphysics and stuff, and I didn't feel like listing them because yes. What?
So the weatherman with a blue screen, is that augmented reality or augmented virtuality?
Yes. Yeah, essentially you're using the green screen, so you're projecting him into the virtual world. So it depends on what there's more of, in a sense. So
He's more like Mary Poppins.
yeah,
Flying
exactly.
through the weather map.
Exactly. Yes.
You said that the system processes the incoming images at 60 frames per second, but is the output affected by the processing?
And it's not always 60 frames per second. I mean, it could come anywhere from like 1,000 frames per second. This one uses 30 frames per second. But the output, that's not actually the thing. Image processing software has increased and advanced so much lately that it's at almost irreducible complexity from what I hear. But I think that everything can get more efficient. But I think it really relies on how many polygons you're actually rendering. I had some pretty primitive models. If you're rendering millions of polygons, that's the thing that's actually going to kick your processor up. Getting this, I actually have pretty good stuff in my computer right now. I did all this with my laptop, a 5-year-old laptop, and it worked almost just as nice. So, the only reason I didn't use my laptop is because I put Windows 10 on it and everything broke. So, yes?
Did you have a specific type of camera to track all that?
No, I just bought a camera from Walmart and that was it. I actually successfully did it with a $5 camera that I had 10 years ago. Or, well, maybe 7. 10 sounds like a really long time. All right,
Great job. Good job.